here we are interested in getting the equation for the average DC load current, that is IDC in case of the full wave rectifier. But before we derive this equation, let me revise this or make you one thing very much clear. Here we are considering a sine wave. This is the normal nature we know, and the equation for this sine wave can be given like I am sine omega t, right? So that can be the value here. This sine wave, it is called as, this portion is called as positive half cycle, this is called as the negative half cycle. So here also it is called as I am sine omega t. But in case of full wave rectifier, what we are getting, during positive half cycle we get this waveform. So that's why for the positive half cycle, that is from 0 to pi, the value of the output can be given by this I am sine omega t. But during negative half cycle we are not getting this, we get the output like this. It means it is just 180-degree phase shifted in comparison with this normal sine wave. So if this is I am sine omega t, this should be called as minus I am sine omega t, right? So it means that in case of full wave rectifier, from 0 to pi we get I am sine omega t, from pi to 2 pi we get minus sine omega minus I am sine omega t. Here don't get confused that this due to this negative sign. Here actually we can write this as I am is positive but the sine term is negative. We can understand it very well like this. For pi to 2 pi the current IL is positive but sine omega t term is negative. It means here we can write like that, I am in bracket minus sine omega t. But instead of writing this, we take the minus sign outside and we get this. Is it clear? So with this we will start. So this is the one thing that all of us should know before going for the equation of the full wave rectifier. Now what we can write here, the equation for the load current, that is IL, is equal to I am sine omega t for the phase angle 0 to pi, and the value of IL is minus I am sine omega t for what angle? For angle pi to 2 pi, right? So this is what we are interested. Now in order to get the DC value of this current, we have to write its equation, which is called as IDC, and we consider the total complete one cycle. That's why it is 1 divided by 2 pi, and integration limit will be from 0 to 2 pi of IL. So this is the equation for the average DC current. Now what we'll do, we'll put the value of this IL from 0 to pi and pi to 2 pi. So accordingly the equation can be further modified like in bracket. First it is from 0 to pi. We will write the value of IL for this 0 to pi. So we know now it is I am sine omega t, this d omega t, plus, so I will write here, plus integration limit is from pi to 2 pi, and the value of IL is now this. It is now minus I am sine omega t d omega t. This bracket is now completed. So this is the equation for the average DC load current. Now this equation we will solve. So we can take the IM outside. So if the IM is taken outside, we are remaining like this, IM by 2 pi in bracket. Now the integration of sine omega t can be like it is minus cos omega t, minus cos omega t, and limits we have to put here. That's why one more bracket we can take. Limits are from 0 to pi. Now this minus sign I will take outside, that's why it is minus, and again we are having the integration of sine, it is minus cos omega t, and bracket is again completed with its limits which are now pi to 2 pi, and further the final bracket is completed. Now simply by solving this we will get the final results. So let us solve this. So here we are having now Im by 2 pi, and in bracket now this limits will be putting. So if this minus sign is taken outside, we are having in bracket cos of pi minus cos of 0. Okay, now this minus if taken we get plus, and in bracket we are having now cos of 2 pi minus cos of pi, and bracket is completed. Now it's simple, we can put the values of cos pi, cos 0, and we'll get the final thing. So here it is Im by 2 pi, in bracket now this minus as it is, and what is the cos pi, it is minus 1. What is cos 0, it is 1, but this minus sign is there, that's why it is minus 1. Now plus what is cos 2 pi, it will be 1, and minus sign, and cos pi is minus 1, so minus minus, that's why it become plus. So in this way we are getting this. Now further solving, it is Im by 2 pi, this is Im, in bracket we are having minus 2 minus, that's why it is plus 2, and this is also plus 2. So actually it is 2 plus 2 4, and this is 2, so this equation comes to be 4 Im by 2 pi, right? So this 4 divided by 2 will remaining with 2 Im by pi, and that is nothing but our final equation. So the average DC current in case of full wave rectifier is twice Im by pi, that is the equation.